One's on my camera, I'll have to like export it.
There.
It's also good to just check. Z0 routine. If it freezes, immediately close the program, Control-Alt-Delete, Task Manager, close it, reopen it, try it again. Normally works after the second time if it freezes. XY zero routine, that one's just like easy. No like enter or anything, it'll just do it.
So it's going to bring it to the correct position.
Okay. And doesn't actually zero it to the material, it just zeroes it to this.
Okay, to the base.
To the edge, yeah.
Okay. All right. So now we're almost ready to go. We've already warmed up the spindle. We've got a new bit on there. We don't have to do anything for the next 4.
Yep.
All right.
No zero.
Tool 0, say okay.
And then file, part file load.
Okay.
And if you ever, like, if this ever doesn't pop up to here, this is all in, desktop user files.
Okay.
Accelerate for cutting.
Okay.
And then I put all of them under the updated files.
Okay.
And you can see here, it's like this one we're doing right now. It's ×6.
Okay.
And this is also the smallest file.
Okay.
This is the like mega one that I think has all the half laps. And this is like the medium has some.
Okay.
I don't know. Anyway, so you just double click on that. It'll come up. If you want to preview, you can hit preview and it'll switch modes.
Okay.
Oh. It's always weird. Well, if I can figure it out.
All right. So don't preview.
Don't preview.
All right.
You can preview if you just like mess around with it.
All right,
But anyway,
so let's go file.
file in,
First
that
one.
one.
Boom.
and then start.
All right. Make sure everything's clear over here.
Yeah.
No one's around
Make
it.
sure that's level.
And then make sure we turn on the vacuum cleaner, right?
Yeah.
All right.
And once that's where it's at. Yeah.
All right. Turn on the vacuum cleaner.
Just gonna remove a whole bunch of material. I actually need to go. Minutes. You're just a little guy, yeah.
Hi, this is our latest video on the Soundgarden 2019 projection mapping project for Accelerate 2019. This is showcasing our final build, and this is an Experience Studio B. You can see some modifications that we have done to make it more stable to withstand higher force winds, and this is now rated for 35 mile per hour wind. You can see we have extended out that base by a foot, almost a foot and a half on either side, and those are bolted down. So what we did was a stress test at the midpoint of the structure, and you can see we have a scale, and we are pulling, about 5 people pulling, and we reach all the way up to 407 pounds of pressure on the midpoint of the structure. Here's some other outtakes from before when we were testing it without any weights, showing rigidity of the structure.
Boom. It just smoothed right out. Look at that. Microphone nice now.
Steps.
1, 2, 3. Busy. Ooh, that looks so much nicer.
Doesn't have exposed wires or anything.
Oh god.
Here we have the first prototype of the wand. We have a power supply. We have a microcontroller, a momentary power button, a thumb wheel, and a 433 megahertz transmitter. Stack these up and hold it. When we press the power button, it turns on the microcontroller. And when it turns on, it transmits out a signal immediately. If we keep it held down, you can see this the red button that blinks here. It will transmit out every second, repeating that same value. We can change the values by adjusting the thumb wheel, and it reads every time we change it and transmits that out. You can't see that in this version here, but you'll see it over on the receiver. Here we have the receiver. It's a receiver module, 433 megahertz, comes into a microcontroller and then transmits out through USB and also gets power through the computer. We can plug that in, connect it to our computer, and we can use this sketch here that I've written in Node that takes the serial data with the OSC packets and then just draws them to the screen. And here I'm going to connect to the COM port, COM63. And then I can take the transmitter that we've got, and when I click on the power, it transmits out to the receiver. Here you can see a value of 65, which in ASCII is an A. We can adjust the thumb wheel a little bit and get a different value. Different value. In this case, all the way up to H. So we can adjust this back and forth. And if we hold it down, it's going to print out once every second. And we can also click the speed that we want. Adjust this. But we can't go too fast because it's not yet optimized, or we may add a capacitor to just increase the amount of time that it stays on with the power so that it can actually transmit. But that's it. This will allow multiple devices out there to be transmitting with one receiver to receive all of these. This module right now is not the final module, but it's good enough to prototype with, and essentially this is how it will work, but should be a little bit more robust, especially once it's not on this perf board.
Here's a short video about the electronic circuit board software that we used for the simple wand. This is called KiCad or KiCad. Here we have the schematic layout. We can see all the components and how they logically connect together. So here's the microcontroller right here. We also have a connector so we can program the microcontroller, some buttons, some mounting holes for the bottom plate, a component to drive an infrared LED with a MOSFET or transistor, a place for the antenna that we designed for it, a place for the color LED, the location for the batteries, and some other connectors here for the antenna module, the transmitter module. Once we have those parts and we link them together, we assign different shapes to them, and then we bring them over into this other tool as part of the package where we can begin the layouts. The actual form was created in sort of an AutoCAD like software. It was actually based on a Home Depot paint stick because it had a good affordance for holding it like a wand, and it was pretty simple shape and had good placement down here for where it made it a bit intuitive for people to hold it right there and have the buttons there. So it actually makes it a little bit easier if we hide some of the fill zones. All right, so down here we have the button at the bottom. We have the place for the microcontroller, a little capacitor, a button, a trim pot wheel that allows us to get different values that go into an analog digital converter, a place to hold the antenna, a custom designed antenna that goes embedded inside the board, and you can also see some of the traces that go up and the different silk screens. We have the MOSFET that powers the infrared LED that we're currently not using, but we'll be able to in the future, and a location for the RGB LED. And we made some cutouts here so that they could fold in the center so you could see from both sides. We also created these custom silkscreen layers. So we have the Accelerate piece right here, the Virginia Tech and the Smithsonian. And then we fill the rest of it with as much copper as we can to give it a little more stability. And we also, in this tool, have a 3D viewer that comes with it that helps us preview a little bit. Many others don't have that. So this is nice and allows us to see what that layout's going to be, and we can add different layers. It even shows the thickness of each of the silkscreen layers as a piece of geometry, so we get a good idea about what it's actually going to look like. And we can change the colors and whatnot. That gives us a really good sense about that and what we expect when it comes back from the fabrication. Usually, I would say 90% of all the PCBs in the world are fabricated in Shenzhen, China, and we used a service there. One of the ones I like to use is PCBWay. There are a couple other ones out there, but for the quantity we needed, this was and the matte finish that we wanted, that was the best option. And that's it about the KiCad and how it was used in the creation of the ACC wand.
start documenting this.
Well, here's the unique ID. Every spit out a value between 0 and 255.
It's crazy that task manager took a spike like that.
Where's it show memory usage in here?
It's good though. It's nice and low. I mean, this is.
What we're hearing is simulation of one click happening every 800 milliseconds, but we can simulate that to be a lot faster. So that was kind of the worst case scenario. If all the wands were clicking at the exact same time as fast as possible, that's what would happen. So we've accounted for that scenario. On the display, I'll zoom in. This is a visualization of every time a sound happens, it triggers the location of the sound to slightly move, and preset sounds are constrained to this 60-degree slice, which will correspond to each form. And the location data here is being handed off to David, so David knows where each sound is located in sort of the 3D space, and he can tie the visual elements to that sound, so when you hear it, you also see it, and they're aligned in the same 3D space. And I'm also not handing off the actual data to David right now, so his rate is a lot slower, but
They're not synced.
Not yet.
No, not yet.
Okay, this is David Franisic here. I'm going to walk through the Max Patcher that I created, it was created for Virginia Tech Accelerate Interactive Sound Arcade. Actually, we changed the name of it. I should do that. it's actually Sound Arcade. Let me change that. Okay. So yeah, this is David Franisich. I'm just going to walk through this Max Patcher that I helped create for the Interactive Sound Arcade for Virginia Tech's Virginia Tech and Smithsonian Institutions Accelerate Creativity and Innovation Festival in 2019. So this Max Patcher basically takes the data from the interactive wands so Tanner Up the Grove created a patcher that receives the wand data from the wands and then cleans up the data and then passes it off to me. And you can see we're splitting the data into 9 groups. And then basically what that does is it takes each of them and gives them their own little interactivity. You can see the 9 modules here. I can walk you through one of the modules. So each module receives the wand data for that group, and then it translates azimuth, elevation, distance into x coordinate, y coordinates, and then a size, and then also we're giving them a random rotation, the animation elements, so that gives some variation in that. And then what happens is we're creating 8 instances of each animation because the animations are loaded into RAM, and so the animations cycle through so that they don't play over each other. Let's see if I can show you guys here. I'm gonna need to start up the background here. This is just playing the background video, the background texture, and then let me pull this down here. That didn't really help me. Okay, so we can test the interaction 1 there. You can see that it's playing right in the middle, and because it's not receiving the data right now, it's not moving it around, but you can see that it is rotating it. And if we go to the second interaction, you'll see that the shape changes, and so on and so forth. So whenever somebody would press the wand button, and they have an ID from 0 to 256 based on the wand dial position, it would split it into one of these 9 groups, and would then be animated accordingly.
The electrician by 2. Oh, there he's at.
Good. If you paint these maroon and orange. I messed it up.
The projector's gonna be right in people's eyes. Video! Then the video.
1, 2, 3. Benjamin.
Do it. You can tell him that I found another one of our
Sound arcading.
doubling up.
It's one of those conditioning things where you feel like you're getting reinforcement, but you're not. There you go. I'm trying to. Is it working?
No,
I can't tell.
Program something and make it look like we're doing something.
Yeah.
So what we are looking at right now is the VT Sound Arcade Instagram. And as you can see, we have posts and we can see who has liked this and commented on them when we scroll over them on the computer. It looks a little bit different on a phone, but you still get the same thing. And we basically posted once a day leading up to the event, and then while we were at the event, just sort of updating our followers on the countdown to the Accelerate Festival, and then while we were there. And so one really cool thing about Instagram is people who decide to engage with us and post photos, they can tag us in their posts on Instagram. So this is what we're looking at right now. And as you can see, they have a little bit more of a following than we do. This video had 225 views. And one thing that's really important about Instagram is engaging with the people who tag us in their posts. So I always try to do that. So then if you click the link in our bio, that takes you directly to our Facebook page. And then just briefly looking at some of our posts, we posted a bit more frequently on Facebook than we did on Instagram. And these were just sort of updates throughout the festival, us setting up, weather updates and delays. And then one really cool thing that we did not utilize before Accelerate Festival was the Boost Post feature. This is where you can pay a certain amount of money to reach a particular demographic on Facebook with your posts. So this is a great way to promote the VT Sound Arcade, just so that we can have maybe a little bit more of a following before future events. And it's a really cool feature. You get to pick your demographic based on their interests, so that's definitely something that we should explore in the future. And then another really cool Facebook feature is the Facebook Live video. This is something that I explored the night that it showed, and this is a live broadcast to the people that follow us on Facebook, and they see those updates, and it basically shows off what we're doing at that moment, and then you can save that video and everyone can see that later if they missed it. But it's a great way just to keep everyone updated with what we're doing in the moment.
Then circle back and back a second time. So he said, I don't mean to alarm you, but there was a homicide on the trail here. Wow. I forget if it was that day or the day before, and he said it was in broad daylight. He said it was almost 13. I'm not sure that it was identified as the body. Keep going.